Not doing my job here.
Hey, everybody, greetings. It is the 247th episode, ladies and gentlemen, of the SBAU Astro Hour. SBAU is Santa Barbara's astronomical unit. Santa Barbara, California's longtime telescope club, based right here at our city's Museum of Natural History. The Astro part stands for our favorite branch of science, and doggone if it's not a full hour every Monday, 11 to noon. If you don't know how much fun we gentlemen on the Zoom screen have doing this every week, wait till you see what we go through in a few minutes here after I introduce everybody. My brain trust is on the screen. My name's Ronnie Herron. Here's a rundown of this week's cosmic topics for November 17th through the 23rd, 25. Welcoming, if we could only see them, the Leonid Meteors tonight. Good luck. Close to midnight. They also peaked last night. Auriga, the charioteer, rides high in the sky this evening with several deep sky messiers inside. The European Space Agency's Mars Express orbiter is showing red planet features suggesting, get this, there might have been an ice age on Mars. It's cold enough there now. All they need is the water above ground, I guess. Another comet named Atlas, but not related to our interstellar visitor, had a close brush with the sun. It's now in three pieces. I suppose it's going to end up like Shoemaker Levy back in 92. Professor Wilson, our godfather on the screen. Yes, what did you? I'll ask in a minute, Tom, what you said.
94.
What?
Yeah. 1994.
I checked it this morning, and I think it said 92, but well,
no, 94.
Well, 94 was the impact. 94 was the impact.
Mm-hmm.
Well, it wouldn't do the same thing on the sun. It wouldn't give us sunspots.
No.
Places around the sun like it did on that big Jupiter. What is it, a brown dwarf? Speaking of the ESA, it shipped the Artemis 4 Orion surface module to NASA, get us up to the moon again. Several major November solar flares are, among other things, giving us widespread auroras. I think they can even see them from here. I've been watching those PBS Nova series about ISS. Had no idea they had such problems up there. Let me check the club out here, sbau.org. Let's see, after, 4 2/3 years of being on the air. And ladies and gentlemen, I'd like to introduce you to the man in charge, our 7 to 8 year old club president who doubles as our weekly professor for these lessons, Jerry Wilson.
Good morning, everybody. Pat's watching this morning downstairs, and good morning to my sister, Joyce, and my grandsons, Calvin and Riley.
I think I'm going to let all 5 of the guys on the screen, including myself, just add our relatives in the future when I introduce, if you don't mind. I love it. I hope they're watching. Here's our club's chief party animal, just to the right of him on my screen, having hit the road. Have scope will travel some 200 times a year. Ladies and gentlemen, Chuck McPartlin, outreach coordinator.
Good morning.
His wife is also named Pat, and she's also an incredible treasurer and runs all our merchandise. Tom Whittemore is on board. We only get the best here at the Astro Hour. Tom?
Hi, morning.
Beloved science professor for many years with his own lab out at Westmont, now retired, edits our newsletter. What was it you said a while ago that something about, the year was wrong on Shoemaker Levy?
Yeah, I remember it because it's right around my birthday in 1994.
I remember I was looking it up in an Astronomy magazine over at the downtown library. Well, doggone, here is our club's chief, what would you call him? A cosmic curiosity like me. He loves this stuff. One great club character, Tim Crawford.
That's it. You got it. I'm the curious guy.
Talked himself out of being one of our speakers in December again. We're going to get you next year, though, somehow. In the meantime,
and Tom's the guy that taught me everything I know.
Tom who?
Boy, are you in trouble.
Well, the other Tom on my screen. All right.
Oh, yeah.
We are missing Bruce Murdock, who is president of the Theater Organ Society in town, but he may join us in time, or he may be doing it. I want to give your wives credit. Whittemore is married to Maureen, and Tim is married to Karen, and they're really supporters of ours. Let's go to the silly stuff. I just told everybody, and I'm going to tell them a couple Fridays. There's a reason to join us at the beginning, have the levity with us, with our forwarded silly science cartoons from President Jerry Wilson. And here they come, ladies. Oh, now, come on. Oh, you did have this one on. something
Oh,
about
yeah. I remember
my anesthesiologist. Can you read that better than I can, Jerry?
Yeah, my anesthesiologist offered gas or hits with a boat paddle. It was an either or choice.
Okay.
Cool. I love it. Corn at its best.
It is again. We could take it. All right. This is. I assume these are humans, right? These aren't foreigners. They're definitely stick figures, and they're at a protest rally. And the guy with the bullhorn says, "What do you want?" And they're supposed to say freedom now, but they say acceptance for the block universe theory. And when do you want it? Well, the distinction between past, present, and future is only a stubbornly persistent illusion. That's what I would chant.
It lacks hitting power.
What were they protesting against with that? Uh-oh. Currently, they celebrate 4th of July on exoplanets. Here it is, the kaboom intergalactic fireworks. Chuck, what you want to get us through this one? Read it to us.
Okay. The adult customer alien says, Junior wants to celebrate his birthday in style. Do you have any new arrivals? And then the fireworks vendor says, sure, 3i Atlas is having a blast with kids. Recently, one reached the Milky Way and straddled. I think they mean startled.
Yeah,
some
startled.
creatures living there.
All right, so it's our visitor Roman Candle from another exoplanet.
And he's actually holding one of the depictions of Oumuamua, which was the elongated one that came by earlier.
Yeah.
Well, Kim Kardashian's got this posted in her bathroom, I'm sure. I'm with Joe Rogan. All right, serial killers versus parallel killers. What about
That's for you electronicers.
Yep.
It's a circuit diagram.
Okay. These are two gentlemen explaining the Northern Lights. How about you, Tom Whittemore? What are we looking at? Explain this to us.
Oh, it's the color wheel. But speaking of Northern Lights, I just got from a friend this morning an image taken on a camera, just a handheld camera from Boston, in Boston, and the lights there are just amazing right now. Okay.
Why do they do different colors? Is that those different elements we see in nebulae?
Yeah, it's different elements.
So if it's a green that turns oxygen and
Oxygen, oxygen 3.
and pink says we got a lot of hydrogen.
No, the reddish that we see is usually nitrogen, and the oxygen can appear both green and red depending on the pressure and how ionized it is. So you get various colors.
Wow, that's confusing.
Yeah.
Sure, this will be a topic someday soon on Jerry's talking points, but are those suckers are protons, but they're not coming in at the speed of light, are they?
No.
They're coming in fast, but it's solid protons mostly.
Protons and electrons.
Electrons.
Electrons and protons from the sun, but not light waves.
Well, certainly we're getting those, but not at night.
But there's a different speed involved. Light, okay, not at night, of course. All right. Do it again, Jerry. Dennis, there were several others.
Well, no, you haven't read this one yet.
Oh, Tom, read that to us. What the guy telling
You know, when you get up here, the Northern Lights are much less impressive.
God.
Another conspiracy theory. All right. How about you, Tim? Can you figure this one out?
I can't. Friendly reminder that out of the entire animal kingdom, otters have some of the highest dexterity and tool usage, apart from humans, of course. And then something at the bottom, I don't get that. Idiot at the round table. He has fallen victim to a phishing call.
Shouldn't that be spelled P-H-I-S-H?
Yeah.
Okay, got it.
So he's holding a fish up to his ear. He's like it's a cell phone, Tim.
Oh, okay. Yeah, I didn't get it.
Hey, have fun. Okay, all right. Jerry, you want to run us through this? They're camping.
Yeah, this guy, it shows the guy pre-dawn in his tent. First one awake, and he comes out of the tent, is the first to receive the Constellation Prize.
I like that one. I like that one.
Play on words. It's constellation. They put in a T. All right. Can you enlarge it? They're sitting around the camp. Oh, this has got to be, the movie, the First Contact.
Oh, God.
Yeah, they're looking at the screen, and oh my God, the program has detected a signal sent from another galaxy. Gentlemen, ladies, we need to upgrade to a paid version before we can reply.
Yeah, boy.
This is similar to a Brewster Rocket cartoon that we had earlier.
Yeah, I
There's
guess
several cartoons on this theme, yes.
Yeah.
you need a username and a password.
Yeah.
Lord. Okay. Is there any more? Because our
Nope,
ugly.
that's all the tunes.
Well, that gets us in a good mood to get serious and do our Broida Hall physics lecture now.
And away we go.
All right, to the night sky, which is behind gray, rating on us.
Okay, this is the early morning sky. It's 3 a.m. You can see that up here. This is the east where things rise. We're getting into this is the galaxy, what is it? The Virgo cluster of galaxies, Coma Berenices cluster. Coming up, this will be overhead in the evening in March. But tonight we're looking at Leo, because this is the radiant for the Leonid Meteor Shower. So you see the best, if you see one from in here, I guess the actual radiant is just above Regulus up here. But the showers or the meteors will appear to leave from out there. So the best view of a long trail is out here, down there, and up above.
Jerry, why is it above Regulus? I don't get that. Is that where, I mean, it's obviously a tail of a comet, right?
Yeah, it's just where we're heading at that time and what we're running into.
Okay.
So it's the above Regulus because that's where Astronomy magazine says it is.
Oh.
And the peak was actually this morning, the main peak.
Okay.
And it's only 15 meteors per hour these days. It used to be pretty spectacular back
Yeah,
in.
but they're supposed to be good meteors when you see one.
Yes, yes. Few but decent ones.
Okay.
Well, I'm sorry, gentlemen. I just have a hard time understanding why the trail of a comet would somehow be only in one part of the sky.
Well, it's actually just a small tube of debris relative to the size of the sky.
Yeah.
As we orbit, that's where we run into it.
When you're driving through a rainstorm, Ronnie, the raindrops appear to be coming from one place dead ahead.
Yeah, that's true.
Because you're running into them.
And you're on double wiper speed.
Yeah.
I have been lately. Okay. We have a lot of those, though, during the year, don't we?
This is a very interesting photo. It's a composite photo of the Leonid Meteor Shower from 2020. You can see 1, 2, 3, 4. That's Andromeda, and 5 here. And there are multiple exposures taken, and this one apparently came first. And these are smoke trails that it left in the sky that the wind is blowing away, that was taken when these other pictures were taken. So he had this set up and he took exposures of a certain length at certain times, and then he put them all together in a composite. One of them showed this meteor streak and the other one showed the meteor smoke dissipating.
Yeah. It's interesting, Jerry, so you can see M33 in this photo.
Yeah. Oh, M33, I didn't see
That's
that.
31 on the right, 33 on the left.
Yeah, there we
It's
go.
the star that
Yeah.
splits them right in the middle
Yeah.
in Andromeda.
And he put in a fake horizon.
Yeah.
Yes, that's obviously a fake horizon.
Smoke from the meteor?
Yeah. Debris coming off the meteor, dust.
I didn't know it was smoke.
Sometimes they leave a trail
Yeah.
of hot particles.
Well, how can the big one on the upper left leave 5 or 6 trails?
Because it's multiple exposures, Ron.
Oh, I see. I got it. Moving the camera's moving.
No, the camera's still pointed the same way, but he took multiple exposures and the wind was moving the smoke trail.
Mm-hmm.
Oh, the wind, not the turning of the earth.
Yeah.
Didn't go that fast.
Meteors cool off unintentionally by a process called ablation. The part of the meteor that gets hot blows off as a tail.
Ablation. That's what I heard lately about 8-fifth. There's something about that.
Yeah.
Okay.
Okay, now what have we got here?
These are the clusters in Auriga.
Oh, that's right. So anyway, this is this always confuses me because when I look at the sky, I don't see this pattern.
Mm-mm.
I see this one here,
Right.
this as the base, and this as another a wall, sort of a house.
I
And even
agree.
though-
I agree.
Right. It's because El Nath belongs to two constellations.
Yeah.
El Nath means the butting in Arabic, and it belongs to the bull and to Auriga.
What does it mean? Butting?
Butting, like a butting bull or ram.
Oh, okay.
So a wild horse trying to throw you a rider off.
Yeah. See, it's right on the border, Tim. Right on the
Yeah,
border. El Nath.
it wouldn't be a butting. No, I mean it would be like it's part. It wouldn't be translated as kind of a part of both constellations. No.
No.
No. It's just a star that's shared by Taurus the bull and Auriga the chariot.
Okay.
Yeah, because these constellation boundaries were done in 1930, so Arabic names wouldn't have had anything to do
Right.
with it.
Okay.
Tim, sorry for butting in.
Yeah.
Yeah, I see it like Jerry does. I just see it as a big oval.
Yeah, big
Yeah,
bent
so these-
horseshoe.
I picture these things as two are inside Auriga and one is outside.
That's right.
Exactly.
This line
Exactly.
here. So
And of them,
every time I
37
see
is
this
the
map,
most
I go,
interesting.
oh, I got to look for those. Then I thought, no, I know those.
Yeah.
So anyway, they're very interesting things. They're all young open clusters.
Mhm.
Young meaning they've just left their phase of being a nebula and they've condensed into a few hundred to a few thousand stars. And then when they turn on, the solar winds from them blows the dust away. And then they, for a while, not a long while on astronomical time frames, but a short time, a few 100 million years, they're a very pretty open cluster. One of these is one of 5 open clusters that has a planetary nebula in it.
Oh.
Now, this is another picture based on where these things are. And this has the bottom line of Auriga that I
Right.
like.
Right.
And you can see it's near this nebula IC 405. And here's M36, 37, 38.
Whenever I look at this constellation in these 3 clusters, it's always I always get lost when I think I know one of them's outside and they're not in order. It's not like 37,
No.
38. It goes 36, then out to 37, back in.
Mhm.
So this is M36. These are all Messier objects, although they weren't first discovered by Charles. So anyway, this one has got a lot of hot blue stars. You can see that, and you can see a lot of the background stars are reddish. Now, it's not that there are so many red stars. Actually, red stars are the dominant star we see in the sky. But I think that there's still a lot of nebulosity hidden in here and makes these things red. But real bright red ones would be red giants. But the cluster is made up of these young blue hot stars.
Do hot blue stars gradually evolve into the reds, or do they just die younger?
Both.
Both
Yeah.
happen. So
The
maybe the reds
color-
started
The color of a star, the true color, not anything faded by dust, but the true color is indicative of, as you all remember, the temperature of the surface. And blue are very hot stars, sometimes up to 50 and 60,000 degrees, where our sun is 5,800 degrees surface temperature in kelvins. So these are very hot stars.
our sun's in between. It's not a red or a right
Our sun is I've heard it described as a yellow dwarf.
dwarf.
Yeah, we're
Well, I'm
a
not gonna
smaller
stand for
star.
Anything that's not a giant is a dwarf, Ronnie. It's another weird astronomy thing.
But most stars you can't even see because they're red dwarfs, aren't they?
Right.
Wow.
Now, in this, there is a feature. Let's see if we can find it. I found it the other day, but I don't find it again now. Anyway, there is an infrared object in there too. And this is it. the infrared object in M36. And this is what it looks like in optical hydrogen alpha narrowband light. This is in the near infrared. You can see this structure. So it's quite red. Now, when you see blue in near infrared, it's not going to be blue to regular film. This is at the shorter end of near infrared. And this is in the mid infrared range, 3.6 to 4.5 microns. And this was taken, it's fairly low resolution, but it was taken by NASA's Spitzer Space Telescope. And it's really bright at that thing. So it's definitely an infrared object. And this is in the cluster.
Look at that trail, from the near infrared and the 4.5 micron, and the one in hydrogen alpha, just you can't see it.
Well, you can see some of it. It's a jet. It's a jet coming out of a young forming star.
Oh, okay. Oh, okay.
I thought we couldn't see infrared. We needed a web to be able to see it.
You can, but our telescopes can see it, and then they make a picture in false colors that our eyes can see.
Your scopes can see infrared?
No, but you can make a telescope that sees infrared.
You need gold on the surface?
Not necessarily.
Okay.
Just a sensor that's sensitive to infrared.
But we got the best there is out there on that $10 billion orbiting scope, don't we?
We got 3 or 4 infrared telescopes out in orbit, and you can get some infrared information from mountaintops here where there's very low atmosphere and not much water above them. Spitzer is a satellite.
But with your scopes, what would you see there? Nothing, or?
No, my scope, you would see, if I were to take a picture of it from my backyard, it would look like this. Because we can make our backyard telescope see near infrared. Silicon is the element that our cameras are made out of, the light sensitive things. And they can be made to view things very inefficiently out to 1 micron, which is so from 6,000 angstroms to 10,000 angstroms, that's the near infrared. It's actually the red part. But we tend to block that part with filters to avoid it, because if you have a refractor, the infrared will make stars look blurry because the detector can detect that, but the lens won't focus it. They weren't made to.
And on that topic, Jerry, Matt Hall made that camera out of the Korean War reconnaissance lens that he got.
Yeah.
And it turns out it was optimized for infrared. So he has all kinds of distortion. He took some first images, and he has all kinds of distortion away from the center. So it's like it's showing really strong aberrations, like coma around the edges. And it's not bringing all the light to one focus. So you get this very enlarged image of some of the stars. And so I sicked him on you to ask how to fix that if there's a way. I was thinking his best hope is just to stop it way down and make it a longer focal ratio. But
yeah, he and I have been exchanging emails on that, and he found a manual for his lens. And it turns out that almost all of what he's seeing is spherical aberration. The lens was never intended to operate at fast speeds. It was always meant to be stopped down.
Okay.
So that's how they achieve the wide field of view. Because it was meant to photograph, I think, 18 by 18 inch negatives, which is quite a wide field.
Yeah.
Because
18 by 18 inch?
Yeah. The planes that are taking reconnaissance pictures don't want to keep going back and forth to get high resolution. They want to just flash through the enemy's field very quickly and be gone.
Is this the fellow we have coming in December, Ronnie?
Yes, that's the guy. He'll talk about all this.
Would that lens be similar to what's in night vision goggles?
No, completely different effect. Night vision goggles take in they have an amplifier in the detector. They're cascade detectors. I forget the name for them. But one photon comes in and it produces an electron pair, and then internal in the detector, that photon pair creates a stream of electrons. So it's an amplification effect. So for very low light levels, you have all these electrons produced in a cascade, and they produce a bright spot on a phosphor, and that's why you see green. The field looks green.
And anything with heat, like a cow or a human in the dark, just stands out.
That's far infrared. You and I and everybody else, all humans, we look like light bulbs at 11 microns. We're the major source of light in a room.
Got it.
At one of our science fair events that we had a couple of years ago at Foothill School, right near where I live here, there was a guy from one of the companies here that does the infrared detectors. And he had this, $50,000 device that he was showing the kids. And he gave it to me. He said, "Don't drop this, of course." And he said, "Watch this, watch the ground." And he walked, and his footprints were glowing. I mean, it left glowing footprints behind him. It was so sensitive.
Wow.
Just an aside, guys, I wanted to ask this earlier. We used to have an infrared company down in Carpinteria.
Company?
Yeah.
Called?
I can't remember their name. That's why I brought it up.
I think it was something infrared,
Yeah.
Infrared Industries or something like that.
Yeah, we have Infrared Industries, but that's in downtown Santa Barbara. And
well, there was one there.
They make infrared sources.
Ah, okay.
They made the lens or the cameras or what?
Sources.
Oh, just sources.
Yeah.
Well, they sold the cameras to the public?
When I retired from Raytheon in 2006, I joined a friend of mine who was running a place, a startup here in town called Cyan Systems. And one of the projects we had was making an infrared television set. So the picture was infrared. So, people can't view it. They don't see anything. So what do you think an infrared TV set was for?
Night vision flying in an airplane.
It was so that you could get a Sidewinder missile that's on a plane and you want to make sure it's good. So you let it look at the TV set and it can see in the infrared, and you move a target around in the field of view. And if the missile's tracking it, you say, okay, that one's good to go.
Ah, okay.
Wow.
But on the color spectrum, you have Roy B. Give. R is the red, and it's the lowest of the frequencies, right? And right below that, the infrared we can't see.
Right.
And what's the one above violet? Ultraviolet, we also can't see. And then it becomes radio waves one side of this place in the spectrum, and gammas and X-rays on the other. The higher.
Hard X-rays and gammas are the same thing, and that's as energetic as we've seen.
Is that right? Wow.
Oh.
This is another cluster here. Yeah. This one is dominated by red giants. And I think it's in a slightly clearer region because the background stars don't want to become red. So this is M37. And nice little feature right there, but that's probably on the other side. So oh yeah, that's right. Now this one, M37, is actually we're in one arm of the Milky Way, and this is in the other arm of the Milky Way. So this is a reconstructed, lately, it's the current view of the Milky Way. So this one is the Perseus arm out here. This is the Orion Cygnus arm, and the solar system is here in this one, and I forget where M37 is, but it's not in the same arm we're in. It's either
I think it's the next one in the Perseus arm, because we're looking out in that direction.
This one, yeah. Okay. Yeah, this one is in sort of a, what would you call it, a spur.
Yeah.
And we're in the Orion Cygnus?
Spur or arm, depending on who you talk to.
The spur is right here. We're just in the inside of the Orion Cygnus right there. It says solar system. And this is roughly our orbit around the, going this way, I guess, around the bar that is the center of our galaxy. We were recently, within the last decade, I guess, decided that we are a barred spiral.
We're halfway between the center of the bar and the edge.
Yeah, so drinks are on the house here.
Yeah, right.
So Jerry or Tom, I know that one of these three M objects is more brilliant in a telescope. Is it 37?
It's 37.
Okay.
That's a showstopper, Tim.
Yeah.
Yeah.
I've-
Yeah.
I've got the apparent magnitude in the talking points.
We're gonna go after that, Tommy, next time
Okay.
out.
Yeah.
And this is M38. It blends more into the background stars. However,
Yeah.
you want to make the background, this one blends in with it. And this is the IC401, I think it was, that we had in the chart earlier. And these are M36. No, this is M36 and this is M38. So this is the bigger, brighter one of the two. And then this is the background nebulosity of it. And so
That whole area is really full of it.
what's that? This area?
That whole area is really full of it. Yeah.
Yes, it's faint.
Some of us are considered to be full of it too. Okay.
That's a different hole there. Okay. It's a great area. Now you won't see these visually. You'll see this visually and this. The rest of these things, you need to take a long exposure or many subframes and stack them, which is what they did here, because if it was one frame, you'd see all sorts of satellites and airplane traffic across.
Yeah.
Oh,
Okay, now the European Space Agency has looked at a portion of Mars called Colo-Facet, and these streaks, these gouges and gullies and stuff, are strikingly similar to what glaciers produce on the Earth. And after much debate and information gathering, they've decided that this represents a period of an ice age on Mars.
wow.
So there was not only water on Mars a long time ago, there was frozen waters and glaciers
On the surface.
on the surface. And there's apparently frozen water right under the surface, because we landed that one just north of the South Pole and it dug down right under itself and it immediately hit hard ice. So there's a lot of ice under the soil, at least in that region. Now, this is an oblique view of that same region. You can see wrinkle or flow patterns here, typical of scraping from ice moving and being pushed around the glaciers.
Wow.
Someday this will all be hotels.
That'll be Mars's Yosemite Valley.
Yeah,
There's El Cap there on the
it would
left.
be much more dramatic valleys on Mars because the gravity's less.
Well, where did the ice go? Did it go underground or evaporate into space?
Probably both.
I was watching a show, Ronnie, on this how the universe works the other day. They were talking about how solar winds blew the atmosphere away from off of Mars, and it was once had a lot of water. And one of these guys, or many of them, suspect that there's water underground here still.
But
I don't know how you guys hear that
Yeah.
given its orbit, it wouldn't have enough heat to melt or to turn it into gas at any point.
No, it does. If you take a bucket of water and stick it on Mars now, it would turn to ice first, and then the ice would sublimate directly into vapor and be gone.
Yeah. It all started when Mars lost its global magnetic field.
Yep.
Wow.
I think magnetism is going to be the key someday, guys.
Yeah. We're going to talk about magnetism next week a bit.
Great. I love it.
Okay.
When we see a cloud here on Earth, we're not seeing the gas, the water gas. We're seeing little droplets, aren't we? Little solidified liquid in droplet form. Because if it were gas, it would disappear. And aren't there clouds on Mars?
Yes.
What are they?
Water vapor and carbon dioxide vapor.
So they're little crystals. They're little frozen. or are they?
Yeah, but at very, very small sizes.
Huh.
Most of the clouds actually on Mars are dust.
Yeah,
Yeah, the red
yeah,
clouds,
yeah.
but they get
Our la-
white water clouds too.
They
Yeah.
think our last ice age was what, 10,000 years ago?
Hmm.
About
We had
that.
the large elephants with the tusks, the mastodon.
So this is Comet K1 Atlas, not 3I Atlas, not the one that is from interstellar space. This is one of our own local homegrown Kepler, or what is it?
Newtonian
No,
Kuiper belt. Kuiper belt.
Yeah, the Kuiper belt. Kuiper. People want to call it Kepler belt. Kuiper. Yeah. And it just went around the sun, and the head of the comet has broken into 3 comets now. These will gradually drift away from each other. Broke up just like Comet Shoemaker-Levy, which broke up into 9 or more particles before it crashed into Jupiter. These probably won't last another circuit around the sun and back again, but I don't know the orbital period of this.
Wow. Are they together or many miles apart, you suppose, those 3 parts?
Well,
Well,
they're
these are-
continuing to spread apart. They're many
Yeah.
miles apart to show that way.
Yeah.
But it's also classified as an atlas, even though our interstellar visitor,
Ron, Atlas is just the system that discovered it.
I understand that, but you would think they'd give some different delineation to visitors.
They do.
Leave.
They do. This is K1 Atlas, 2025 K1 Atlas, and the other one is I3 Atlas.
Okay,
Yeah.
did they
There's
call
another
it
one, Ron. There's another one.
what?
Yeah.
Which one?
Charles Atlas.
Charles.
Oh, God.
Did they give
Remember those ads on the back of comic books?
Yeah.
Yeah.
So anyway, this was discovered by the Asteroid Terrestrial Impact Last Alert System, spells Atlas.
Mhm.
And when I was, as a scientist, but starting to have marketing duties, I learned the value of having a catchy name for your acronym, and it is valuable in marketing. You can't just, here this is.
They're going to run out at NASA soon. Just a matter of time.
Okay, now going back to something we touched on last week briefly, because they were going to launch it after last week, but they did launch it late. And this is the rocket taking off. It's a New Glenn from Blue Origin, taking off, delivering the Escapade pair of satellites to Mars.
Wow.
And it's a really complicated way they're getting there, to me, it seems.
Yes, but there's a method to their madness. This is an artist's rendition of the 2 satellites in orbit in formation over Mars. And the method to their madness is, let's see, it's a new trajectory path they're doing. If Elon Musk's projection of having hundreds of starships with refueling and everything going to Mars, you can't just like sit around, put your coffee down and say, let's go to Cambria for the weekend. You can't just do that. You have to, because Mars goes around every 2 years. We go around once every 1 year. They only line up, the distance is short every little over 2 years. And so that's when you want to launch. So the travel, because we don't power all the way to Mars. We blast ourselves off Earth and then we coast to Mars. And that's why it takes 7 months to get there. So what they're going to do this time, they're going to try a new thing. They're going to blast off, because this is not the time you want to send something to Mars the traditional way. So they're blasting off and they're going to park the payload in the L2 point near where James Webb Telescope is, the Lagrangian point. And they're going to park it there until the window to Mars opens up. And the reason that they're looking at this trajectory of storing things in orbit on the way is because we don't have enough spaceports on Earth to launch that number of things when the window opens up. They just don't have enough permission to take off. They don't have enough places to take off from, and they can't get that many rockets all together at one time. So they're going to launch them as they become available, and they're going to park them in orbit up there. And then when they're going to sit there until Mars gets into the right window, and then they're all going to take off for Mars.
The Blue Origin, is that Bezos?
Yep.
Yeah, this is Jeff Bezos.
Boy, that surprises me.
And they're going to, and in this case, they're going to travel to Mars using ion engines. They're going to be having a acceleration and deceleration all the way. So it's going to shorten the trip down from 7 months to, I think, 3 months.
Wow, cool.
In principle, if this works.
Yeah.
So they're testing that pattern.
I read that it's not going to arrive until fall of 27. That's 2 years.
Yeah.
That's because they're sitting and waiting in the parking space.
Yeah.
That parking space, is it out? You say LaGrange, is it out next to the James Webb or in that area? A million miles?
It's a million miles out there. It's a big place. Space is not called space for nothing.
It's just going to sit there, and maybe we can aim the web at it and see what it looks like.
No, we know what it looks like. We took pictures of it in the factory.
But what we're seeing on the screen is not going to be taken to Mars by itself. It's going to be, these are going to be inside a capsule, I assume.
No. These things will have the ion thrusters on them and go themselves.
Well, no kidding.
See those big round things?
Yeah.
And communications antennas, I assume.
That's the rocket engine.
Ah, okay.
It's very low power, but it's not millions of tons of power or force pushing on it. These are low rate but steady, and that beats coasting any day of the week.
Have we launched anything before using?
We've launched experimental ion drives many times.
And then, of course, to power all the stuff on board, they'll kick those solar panels up when it gets to Mars.
Probably all the way.
Yeah, because the fuel for ion is the ion, but the acceleration comes from the electricity generated by solar panels. And when you go out to Mars, the sun is dimmer out there, so you need more solar panels.
Now you're going to be able to decelerate. They're going to kick this around 180.
Yes.
Huh.
Are we at Mars on opposite sides of the sun pretty much right now?
Pretty much, yes.
Yeah.
So we're waiting for it to come by. All right.
And this rocket, this New Glenn rocket, also the first stage came down and landed, just like Elon does.
Huh.
Well, Elon's the one that wants to go to Mars with people. I wonder if he and Bezos might get together and pull this off. They got enough money.
They're both welcome to go as soon as possible.
Yeah, one-way ticket.
Oh, whoa.
I don't care if that David. Go ahead.
This is a photograph of the booster for the New Glenn rocket decelerating to land on a barge at sea, just like SpaceX rockets land, and it was very successful. It didn't have a catchy name for the barge it landed on that I recall.
Was that from Florida, Jerry?
I believe it was, yes.
Well, those suckers have to reach, 17,000 miles an hour or even faster, and then dead stop and go backwards?
17,500 miles an hour sideways.
Yeah.
When you get above the Earth, you get up to low Earth orbital position. Gravity doesn't turn off. There's not no gravity up there. When you see people floating around in the space station and stuff, they're not somewhere where there's no gravity. They're in free fall.
They're falling, right?
And so the idea is an orbit is simply that the Earth's gravity is pulling you down, just like you jumped out of a 10-story building. And each window you pass, so far so good. But in a building you hit, it's the sudden stop at the end that kills you. It's not the fall. So the orbit is simply that they shoot you sideways so fast that by the time you fall down to where the Earth was, you've missed the Earth. You've fallen around it.
Right.
So that's all an orbit is. The in orbit where the space station is, the gravitational force there is about 90% of what it is on the surface of the Earth. It's not no gravity. That's a very misunderstood thing about going to space. People claim that the gravity stops at a certain height up and then you're floating. That's not true.
But that's the Lagrange point, though.
No, but everything that's in orbit, if something is traveling in a straight line, then it is falling, it is coasting and traveling along at a straight line. There's no forces on it. If you're traveling in a curve, any type of curve, then you're responding to gravitational forces and you're falling in response to those forces.
That's why the comet vomit gives you 30 seconds, because the damn plane is falling and you're in it.
Right. That's right. It goes in a parabolic trajectory. It jumps up just like a cannon shell. When you fire a cannon shell, it goes in a parabolic trajectory because it's falling all the way. There's no acceleration on it other than Earth's gravity. So if you're inside a cannon shell, until it hit, you would be floating in the shell.
And Tim, the Lagrange point is where the gravitational forces on you cancel out from several objects.
Okay.
Pulling on you. So that's where it's, you can kind of think of that as no gravity or very, very low gravity, but it's because there is gravity there.
Okay, so it's just it's equalized from different sides.
Yeah.
Okay.
But is the Earth in between the James Webb and the sun, or is it?
Yes.
Is it in between? It is?
Yes.
Roughly.
To me, it seems like the combined gravity of the sun and the Earth would overwhelm that. What's pulling from the other side?
No, if the sun wasn't there and you put the James Webb telescope above the Earth, it would orbit the Earth at that distance and it would travel around in an arc around the Earth. But with the sun there, it feels the gravitational pull from the sun and the gravitational pull from the Earth, in this case, in the same direction. And so it's responding to a larger gravitational pull than the Earth alone. And so that the net result of that is it travels faster at an Earth speed. So it can't actually make an orbit around the Earth. It flies in formation with the Earth.
Okay, and there's also other points. There is one between the Earth and the sun.
There are five Lagrange points.
Well, this looks like a big candle snuffer here.
Yeah, this is Artemis 2, and this is NASA stacking it for a test flight. It is produced down here by the European Space Agency. They build these and they send them over to NASA. And this is one being mated to the SLS, the I forget what LS.
Spacecraft Launch System.
Yeah. And this is the winning concept for SpaceX Artemis 3 to land on the moon next year. But they decided that according to NASA, the SpaceX is just too slow. They're too far behind. So they don't have any faith they're going to be able to pull this off on the time scale that everything else has to come together. So they've decided to relet the contract competitively.
Whoa.
Now, I'm not going to tell you what I personally think, but anyway. So this is the concept of SpaceX landing for the first time on the moon. Now he claims this is going to happen in 2027 and the crew is going to be robots.
Oh, for crying out loud.
Which is the one that landed on its side?
This is the way Disney used to. Remember when we go into the rocket ship of the Mars?
Several smaller lunar modules have landed on their side.
Yeah.
And I'm skeptical that I think in order to get this to land this way, you need to have a prepared, level, hard concrete pad to land on.
Yeah.
I just think landing something that tall on just random lunar soil is going to meet the same fate as those other two landers that didn't stay upright.
Yeah.
And Tim, you need Buck Rogers on board too.
Yeah, you do. You really do.
A little further for what was his
Armstrong.
name?
Armstrong went to Purdue.
For Neil to climb down that long ladder, he could probably jump and survive, wouldn't he?
Well, there's an elevator there.
Yeah.
That tube
An
is
elevator. Okay.
Yeah.
Give me a break.
Okay, now we've had a very active sun last week.
Yeah.
This is a satellite picture of a solar flare that resulted in a CME headed toward Earth. I believe it was last Friday, the 14th, 11/14.
Friday.
So what is today? Is the 17th?
It was Friday.
But this was Friday.
Mhm.
So on November 11th, we had a class X 5.1 solar flare. On November 10, we had an X 1.2 class flare. On November 14, we had an X 4.0 class. On November 10th and 11th, we had multiple CMEs. And on November 13 to 14, we had a series of solar storms hit Earth. And if one of them hits us directly on, as I like to say, we all get to buy new computers.
But that's different from prominences.
Yeah, it's like a violent version of a prominence.
Oh,
And these are multiple pictures of that. And I think if I can, let's see. Uh-oh. Can you hear me?
Yep,
Yes.
yep.
Okay.
It froze on you?
Yeah, something froze. I've got control of my local. Are you guys still there?
Yep.
Yeah.
Okay, because I've lost the meeting.
okay.
Anyway, that was the last slide.
You can't see us?
I cannot see you.
Okay.
Well, can you see what the pictures are on the screen? Because we see those.
I see my pictures.
Okay, well, my question is about the sun itself. It turns in different speeds at different levels, different strata.
Yeah,
If you put layers like on Jupiter,
yeah.
and that's the reason we have such a screwed up system of magnetic fields that twist and make these flares happen. Is that,
That's part of it. Yep.
you'd think after so many years it would just explode from all that. It
Well,
doesn't turn
that's
straight
what
and
it's
forward.
doing.
Is that what it? Wow.
One of these Sundays, we're going to get lucky and see a flare. I thought I had one a couple of Sundays ago.
Yeah, we did. You were right about that.
Oh, really?
But it was a sideways flare. It wasn't directed right at us.
Yeah, it was, there was nothing there. And then for about 20 minutes, there was a real bright looking filament there. I mean, well, I'm saying filament, but it would look like a little hair-like, real bright structure. And then 20 minutes later, it's gone again.
Yeah, that's characteristic of a flare.
Yeah.
Yep.
So I finally found one, finally saw one.
But can I ask a question, a big, broad one about the sun itself? Does it have a polar, just like the Earth or any of the planets? It has an upper and left southern pole that's different from its magnetic poles. Like on Earth, our magnetic pole is off of.
The sun doesn't really have a simple magnetic pole like that. It tends to, but the sun is a plasma, and as we'll discuss next week, its magnetic field is a twisted up nightmare of rubber bands all twisted into a ball. So
I'm looking forward to that, Jerry. There you go.
Can you see us now? We don't see you.
Oh, Chuck, you're the host now.
Yeah, I guess I am the host.
Well, Jerry, are you there?
No, he's disappeared.
Yeah, okay,
Yeah.
so he's going to check back in, I guess.
They got
Okay.
him. That damn Atlas 3I, my God, it got it.
Yeah, the
Now it's
flare got
messing
him.
with us.
Or AI has taken over, one or the other. So answer me this.
Ron,
Yes.
there's some really beautiful images coming in from just people standing out, in their backyard taking pictures of the auroras, caused by these events, I guess. And there's one particular one a friend of mine sent to me from Boston. Okay. It's an image from Boston. The image is actually beautiful. So what you can see in the sky is a lot of, pastel colors, as well as the camera was so good. You get, stars in Auriga, Orion, Taurus the Bull. You see the Pleiades, and other details in this image. I think it was just by an iPhone. Really pretty.
Are they having the same thing down in Australia with the southern auroras?
Yes.
Yeah, they should get them. Boston is far enough north that, they're really seeing some spectacular colors in the sky.
I wonder why the incoming, whatever it is, influx of protons looks like a curtain. Looks like they end at the bottom and are ruffling curtains. I'm trying to figure that. Science must know why it does that. Does that stuff crash into the Earth?
Yes, so the Earth's magnetic field acts as basically a magnetic bottle. Okay, and when charges come and hit these magnetic field lines, they circulate about them. Okay, and then Chuck knows more about what they bash into up in the atmosphere to get these colors. That's basically what's going on. These high speed ions are coming in and hitting our upper atmosphere, and basically liberating all the beautiful colors, from nitrogen and oxygen and stuff like that.
Do they have the whole spectrum of colors, or is it just red and green?
Oh, this one I saw that my friend sent to me was just absolutely gorgeous. And, embedded in the background of this beautiful light were the constellations that were easily recognizable. Really, really pretty. Okay.
And on the same note of people taking fantastic pictures, here's one that's kind of gimmicky, but let me share this and hopefully it will show up.
Wonder if we're being recorded still.
Oh, yeah.
Okay. So, Jerry's back. Okay.
I'm back.
So is this showing?
Mr. President?
What?
Who is that falling into, my God?
This is a guy that jumped out of a
the 20 high balloon?
No, yeah, but it was one of those airplanes that's made out of a big prop and something, and he just bailed out of it.
Oh,
and he's got a parachute on, you can see in the back.
Yeah, it's a skydiver, but he coordinated with the solar photographer to get this picture.
Yeah.
Just fantastic.
Look at the detailed structure in that on the sun.
Yeah.
And those are your filaments, Tim.
Yeah,
See those?
exactly.
Yeah.
Those are sunspots?
Sunspots are there too. I can see at least 3 pretty good ones.
Yeah.
And the filaments in the whitish areas, they might be the plages.
Those are plage. Those are probably
That's a
plage.
very high resolution picture.
Yeah. Yeah, that's amazing.
I always tell people the plage in French means beach, and I said it's a hell of a beach.
It's a beach.
You get quite a burn there.
Yep.
Yeah. I guess it's a good thing they didn't use the Polish word for a beach, because nobody could pronounce it. Maybe.
Yeah.
It's a brzeg.
Oh yeah. You tried that with me one day, and I failed miserably.
So
It's a son of a beach.
Back to the solar flares and the auroras. Is that a winter phenomenon? Are they not getting it in the southern hemisphere? Because
No, it's not. No.
It's year round.
they still get it just as much.
Well, there are 2 peaks that happen in like October and March when the alignment of our magnetic field kind of syncs up with the general magnetic field of the sun that makes it easier for these things to enter our atmosphere.
Well, north of the Arctic Circle, it's going to be 24 hours of darkness. Do they get it? Get those things, those auroras, 24 hours?
Yeah.
Oh, yeah.
Not just nighttime like we get.
Yeah. Well, it's nighttime there.
Well,
I mean, we get it 24 hours too. It's just whether you can see it or not.
Wow.
is this the sun we're looking at?
Yeah.
Looks like
That black
X-ray.
area, that deep blue area is a coronal hole where we're going to get a lot of flares out, and there's a lot of activity over here.
Those coronal holes, Jerry, that I was listening to a program again on that, how the universe works. There's an accelerated either the flares or the plasma that blows off the sun.
Yeah,
it
That was a
accelerates
flare
it,
we just saw.
and they couldn't figure out what really accelerates it. And the latest thinking is at the coronal holes.
Look at that.
Wow.
Yeah, and Ron, this is the world I used to work in, the solar labs at Lockheed Research Labs.
Oh, no
Really?
kidding.
But we used to fly satellites or sounding rockets.
Well, then you can answer me the question I was starting to ask Jerry earlier. The sun does have an axis around which it pivots, doesn't it?
It has a
Remember,
rotational
it's a
axis.
gas, it's plasma. So it has extremely complex, Jerry said, complex magnetic field structure. Okay.
for the magnetic fields. But for
Yeah.
the area of the sun that does not move except turning around, like the center of the carousel, on the
Right.
playground.
Just roughly, Ron, in the middle of the sun, the equatorial zone, it takes the sun about a month to rotate once. Okay. And as you go further up towards the poles, it's a little slower. Okay.
And it's
So it
800.
takes longer. It takes longer.
Okay. Fascinating stuff,
Oh,
gentlemen.
wow. That was neat.
I love it.
Next
Look-
week's going to be neat, guys.
Look at those prominence loops.
You're gonna have to come back. Jerry's gonna go into this next week. So
Well,
Yeah.
you people
This-
watching on
this-
YouTube, come on back.
This
Jerry,
picture
what
was
it like
taken
being captured?
yesterday.
Jerry, what was it like being captured by those extraterrestrials? What did they want from you?
What's
You're
that?
back now. We lost you.
Yeah. And Ron, 131 angstroms is, X-ray, soft X-ray.
Okay, X-rays are the highest. I thought gammas were the highest, the fastest.
Gammas are just hard X-rays.
Right. Yeah.
Not
We used to work in 171 angstroms, where
Wow.
iron was, I think iron was ionized something like 17 times or something.
The word
Blasted.
that never shows up in my crossword puzzles, but I do get ergs and ohms and amps.
Yeah.
Let's do this again, gentlemen. Number 248 next week. Our big special month is coming up 2 Fridays away. Our big election and 2 of our own and House members. Chuck mentioned one of them, Matt Hall, along with Dave Grossman. And doggone, that's December 5th at the museum. Let's all bid farewell now the way we do it in emails, and Chuck especially. How do we say it?
Hasta